All right, folks, here we are again. This is lesson 3, and this one actually is going to be a little bit more in depth and require probably a little more concentration. I am coming to you live from my kitchen counter, so there's a really good chance you're going to hear weird noises like dogs and washing machines and all those fun things that happen at home. So we'll give it a try, see how it goes. So we're going to be talking about absolute value, and absolute value, is something that you've seen before. What most people say is, oh, the answer is positive, but they don't really realize what they're talking about or like what absolute value really means. The definition, when you have these absolute value bars saying the definition of absolute value of X, basically is talking about a distance. What is the distance from X in this case to 0? And so thinking about that, we got to make that way skinnier. Thinking about that, looking at something like this with a 3, you're saying, what is the distance from X to 3? Well, I'm looking for a distance of 3, from 0. So if I'm at 0, I could go 3 to the right and be a distance of 3 away, or I could go 3 to the left and still be a distance of 3. So distance is what makes it positive because you don't have a negative distance. That's not like a thing. So X could either equal positive 3 or it could equal negative 3 because both of those values fit this description of being 3 units away from 0. So that's kind of the concept. So as it gets more complicated, because we love complicated here in honors math, we have to think about this problem. If we're solving for X, we're trying to find the values of X that work in the equation. So in this particular thing, if you think about what this means, it's saying what numbers could I put in here that would be 9 units away from 0? So my two options would be either positive or negative 9. Those are not my answers, and that's the most common wrong answer, is just to throw down that value. No, you have to take what's inside the bars as is and say that can either equal negative 9, because then I would have the absolute value of negative 9, which would still come out to be a 9, or I would have 2x minus 1, because you never change what's inside the bars, and that could equal a positive 9, because whether it equals a positive or a negative 9, it will come out as a 9, and therefore be a legitimate solution. So now you solve two problems. So I'm going to add 1 to both sides, and I'm going to end up with 2x equals negative 8. So my first answer option is that x equals negative 4. Okay, or, and then I'm going to give myself a second option and say this other equation would work as well. I'm going to add my 1, same kind of math. I'm going to have 2x equals 10. Dividing by 2, I'm going to have my second option. Now here's the catch. This problem's pretty straightforward and my answers will work, but when you start getting more complicated problems, you will get answers that don't actually work. Those are called extraneous solutions. So when you're solving, you have to check your answer. And I know like teachers usually say check your answer, and you're not going to because you already know it's right. Here, it's very possible that you will get an answer that doesn't actually work when you plug it back in. So you should kind of check and see. So in this case, I would have to go back and say, okay, let me think about this. If I actually put a negative 4 in here, would that actually turn out to be a 9? That would be negative 8 minus 1 more, so negative 9, absolute value puts it at 9, check. Here, I would have to say, what if I took 2 times 5 minus 1? That's 10 minus 1, I get 9. Is the absolute value that going to be 9? Check. So both of those work. So you're probably like, yeah, right, Miss Hadeen, that's always going to be the case. You're just making us check our work. No, I'm not. And I will tell you that these are the problems where you typically run into what we call those extraneous solutions. You're going to run into problems where the solutions, meaning the numbers that you got, do not work in the equation and in that original equation. So they do not work in the original problem or the original equation. So one way I can tell that that's going to be an extra risk is that there's an x on both sides of the equation. Those are the times where this comes into play on a much more regular basis. And if you're saying to yourself, well, I don't need to know that, it hardly ever happens, it's probably not on the test, that's backwards thinking. The fact that it rarely happens and it takes attention to detail to see that it is happening, that's exactly why it's going to be on the test. You're welcome. So, same thinking. How do we do this? Up here, we set up our middle portion equal to the positive and negative version of the right side. So I'm going to split that and do the same thing. So I'm going to be solving two problems. 4x minus 10 can either equal positive 6x, or 4x minus 10 can equal negative 6x, because I have to have both the positive and the negative. So what I would say is that you want to kind of test this out. Maybe stop and try these on your own and then see if you did them right. Otherwise, you can just stick with me and watch me go through this one and do some of the Edpuzzle questions on your own. All right, so I'm in green mode, so I'm just going to go ahead and solve that. I'm going to take my 4x and move it over, because why not? So I have negative 10 equals negative 10x. And don't do that, my brain is on summer mode, and say, well, two negatives make a positive. I'm subtracting 4 from negative 6, so that will become more negative. And then when I divide by my negative 10, x is going to have a value of 1. Okay, so I'm going to check it. I'm going to go back and I'm going to plug in a 1. I do not love busy work. It's just not my thing. But I'm checking because I know that in this scenario, it is very possible that I'll get extraneous solutions. So this would turn into 4 minus 10. I'd have negative 6 equals 6. So this one checks out. So this is a legitimate solution. And on a test, I would have my work. I would have that answer. And I would be good to go. But I still have to find and check my second option. So I go about the math in the same way. I go ahead and take away my 4x. I'll have negative 10 equals, this time be careful, I get a 2x. When I divide by 2, I find that x equals negative 5. That's my second potential solution. So I plug it back into my original problem, and I check, does 4 times negative 5 minus 10, absolute value of that, equal 6 times negative 5? Well, that can't be a solution, because the right side of my equation is negative, and the left side, even if it's 30, negative 20 minus 10 more, which it is, that is going to come out positive since it's in absolute value bars. So 30 does not equal negative 30, and that means this is extraneous. And extraneous, the root word of that is extra, because it's an extra solution that you get when you do the math properly, but it doesn't actually work in the equation. So this is precisely what my work would look like on the test. I would show my work, and the test is Tuesday, remember. I would show my work, and then I would cross out the option that doesn't actually work, so that I, as the teacher, can say, oh, I see all this work you did, I know you understand, and then I see that you checked it and it didn't work. So you crossed it off, that I can kind of go, oh, this kid knows what they're doing. If you just put 1 on the answer line and you don't have any work to support it, and I don't see that you ever got negative 5 as an option somewhere along the line, and that you tested it to find out it wasn't a legit answer, you won't find yourself getting full credit. So I'm just trying to kind of avoid that by telling you ahead of time. So I'm going to cheat, because I clearly am out of room. I'm going to cheat a little bit, and I'm going to take this problem down here. So this is going to be another complicated one where I want to really take my time and say, okay, 2 problems. 2x minus 3 can equal 5x plus 1, just like it is up here. But now I have to set up my other option and say, well, the other possibility is that 2x minus 3, because you never change what's in the bars, like I said earlier, is going to equal the opposite of this side. This one's tricky, because like here, we could just throw down the negative in front of the 6, but it has to be the opposite of this whole side. So that negative distributes, and I'm actually going to be solving this problem. Okay, so since I'm in blue mode, I'm going to keep going with that. I'm going to add this 5x over here, because why not? So 7x, I'm going to add this 3 over here. And again, don't go into panic mode because you got a fraction. We're in honors math. Fractions happen. Okay, so now I need to go and go back to my original problem, the one up here with the bars and everything, and check to see if this is going to work. So I'm putting that in and saying, is 2 times 2 over 7 minus 3, absolute value of that, going to be the same as the opposite of 5 times 2 over 7 plus 1. So you can kind of see why we did the PEMDAS thing. So I'm going to check both sides, and you're welcome to use your calculator. So if I did 2 times 2 over 7, and you got to be careful as you go with your negatives, minus 3, I get like negative 2.42857 and so on. All right, over here, if I do 5 times my fraction 2/7 plus 1, I get 2.4. I get the same number, but I also have to remember to bring this down since that's sitting around outside. So it turns into negative 2.42. Okay, well, that is a problem because if this one would come out positive, that's not going to equal the negative number. And so this one had that negative sign out in front. And so when I find this whole value inside and then take the opposite of it, these are not equal, and that makes this an extraneous solution. Okay, let's do purple mode. In purple mode, I have this solution, or excuse me, I have this problem, which is my original problem, never changing what's in here, set equal to the original. So I would go ahead here. I would probably take away 2x. Let's get rid of that little blob I made. And then I'd be looking at negative 3 equals 3x plus 1. Take that away. I end up with 3x equals negative 4. Dividing by 3, I get x equals negative 4/3. Okay, so if I'm going to plug that in, I'm going to go back to my original problem. So I'm going to take 2 times negative 4/3 minus 3 in absolute value bars. And I'm checking to see, does that equal 5 times negative 4/3 plus 1? So we're plugging in numbers, we're using PEMDAS, we're doing all the stuff that we kind of talked about earlier in this chapter. So I'm just going to take a minute to do that on my calculator. And I messed up because I don't know why. So here I'm getting negative 5.6 repeating, which would come out to be positive 5.6 repeating. Let's check out this side. And over here, I'm getting negative 5.6 repeating. So this one's negative, that one's positive. They're not equal. So I'm looking at that and I'm thinking that this one doesn't work either. Where did my solution go? And so this option is not an option either. And so when neither one of these works, I have to throw down a no solution. So if I'm going to give my final answer on a test or quiz, I'm actually going to say there's no solution because the two possible answers that I got don't actually work in the equation, if that makes sense. Okay, so let's keep cruising here. So now we're getting to some good stuff. This is going to put together things we've already talked about, which is and or. And this is really going to require you to feel pretty confident about those topics. So when you're doing an absolute value inequality, so it's not an equation anymore, you have to know how to rewrite that as a compound sentence. So I always look at this with the x on the left, and then I see this, and I just exaggerate how I say it. I go, oh, that's a less than. So I know it's going to be an and statement. An and statement is like a between. So you're thinking, remember, that the distance has to be less than 4. So if you kind of visualize the number line, and I should do these as open circles, if this is 0 and you have to stay less than 4, it's kind of like being grounded. You could either go to 4 or -4. So you're kind of grounded at your house. You can only go 4 in any direction. So when I write my inequality, I would put it between 4 and -4. And that would be my between or and statement. I need to remember that so that when I set up for solving, my first step is going to be, do I set it up as an and or an or? So here, this is saying the distance is greater than 4. So now if you're thinking about the number line and you're saying, well, here is 0, this is like a restraining order. You have to stay more than 4 units away, so you can't be in this part. So here you're stuck in the yard, and this one you can't come in the yard. You have to stay from 4 on out, or you can go from -4 on out. So how would we write those two statements? Well, this one would be x is greater than 4. And then this one would be x is less than -4. And so it can be in either place. So this or that. And so that's going to be really key to be thinking I have to be outside of. So this is, like I said, the restraining order. You have to stay far away. And here it's like you're being grounded and you have to stay within a certain distance. So when I see this problem number 4, I think, okay, that is going to be a than, an and statement. It's less than. I have to stay within 4 units. So when I go to set up my problem, the easiest way to do that is to write what's in the bars, because I never change that. I steal this symbol from the problem, I write it again, and I think, okay, I can either go to 4 or -4 and stay within that distance. And now I'm ready to solve the compound inequalities from the other day. So the more confident you felt about that before, the easier this will be. I'm going to go ahead and add 5 to all of the parts. So now I'm sitting at 1 less than -2x less than 9. And then I need to divide by -2. Okay, keep in mind, when I divide by that -2, I'm going to need to flip that over. So if I divide each of these by -2, I'm going to be at -1/2. This is going to flip over. That's going to be just x. This is going to flip over, and I'm going to be at -9/2. Alrighty. Well, I should probably write that in number line order, so, or at least graph it that way, because keeping in mind that this -9/2 is actually -1, 2, 3, 4.5, and x has to stay greater, watching that alligator mouth, than that. -1/2, if this was 0, is going to be just right here. So I need to stay between -9/2 and -1/2, and my graph looks like I expected when I determined that this was an and statement. So this is putting a lot of things together, because we do not mess around here in honors math, and so you're really going to need to watch all those details along the way. I see this on my quiz or test, and I say, oh, this one's greater. This is the restraining order. You have to stay more than 7 away, so 7 units away from. So I'm actually going to have to write 2 problems. One is going to be the original problem, where you stay greater than or equal to 7, or, and then the other option, and you never change what's inside the bars. You never, ever, ever do that. So I'm going to copy what's inside the bars, but I'm going to flip this over and use a negative, because I'm either greater than 7 or less than -7, because I need to be at one end or the other of my number line. So this is taking up a lot of space. I'm sorry, this is a little messy. So here I have 1/2 x greater than or equal to 4. To get rid of the 1/2, I'm going to multiply 2 to both sides, ending up with x greater than or equal to 8 as one of my options. Great. Let's take a look at the other option, because this is an or. I need 2 oars to row my boat. I'm going to take away 3. You're just doing the same math each time. Once you have this set up properly, the math should be easy. It's just a matter of making sure you set your problem up correctly. To get rid of the half, I'm going to multiply by 2, and I get as my second option, x is less than or equal to negative 20. So it's either or. So let's say I call this 8, and it's or greater than or equal to, so I color it in, and I head off to the right. That graphs this possibility. Then I'm just going to pick a negative 20 down here because I don't have enough room. And you can do the same. You would just label that so I know you know that that's negative 20. You're going to color it in because it's or equals to, and it is less than, so it goes off to the left. So as soon as I saw that and knew it was an or, I was expecting to get those two branches reaching out. So the last concept for today, and this is kind of a doozy of a lesson, there's a lot of things to like take in. So you may find yourself looking back at your notes. That's what you should be doing when you're working on your homework. This formula, for lack of a better term, is talking about the term tolerance, which you might, like if they say it's going to be 82 degrees, give or take 3 degrees. Well, if it's going to be 82 degrees, give or take 3 degrees, I'm either going to add 3, so it could go up to 85, or I'm going to take away 3, so it could go down to 79. That's kind of my range. And in this case, my tolerance would be the 3. So you're saying, hey, the distance away from the average, so like in this case, the 82, the distance away from that is going to be a 3. That's my tolerance. So this is something you want to know. So when you set a problem up, you're looking for like the ideal, the normal, what's normal anymore? Who knows? But whatever's ideal, normal, average, you're finding the distance from X to that value, and you're keeping it within a certain range. So here, like I would say from 79 up to 85 would be my range. 82 was my average or my mean, and then my tolerance was how far I went in each direction. So if you're asked to write an absolute value inequality representing the range of heights, you would start with your tolerance equation, and you would say, okay, this is my average, because the average US woman is 64 inches tall with a tolerance of 5. So you're saying the difference from any value to 64, which is the average, has to stay within 5 units. Okay, well that's an and statement. So this is my tolerance statement. I'm going to go ahead and solve for X. When it's an and statement, I put it in between the two values. Since you have to stay within 5, you go up and down 5 with a positive and negative. You would add 64 to all 3 parts. And so you have here, you're going to have a range from 59 inches tall to 69 inches tall. That's what you would write if you are asked for the range of heights, and that's inches. If you are told to solve for X, that's kind of the same thing. It says write an absolute value inequality representing the range of heights. So that's the inequality. Absolute value inequality. Solving for X is giving me the actual range. Because you're saying, hey, if 64 is the average and I go 5 in either direction by adding or subtracting 5, my tolerance range goes up to 69 and down to 59 inches, making it a range of 10 inches total. So just kind of think about that, because if they told you in a different problem, hint, hint, foreshadowing, that your tolerance range was 10, you know that has to split equally so that each one would be 5 on either side of your average. So just kind of get a handle on that total relationship between all those values. That's a lot of new information. And so I would take time to kind of take that in and really look that over, because that is a lot of new stuff. And that's going to be the juicy bits that are going to give us the most trouble on our upcoming test and quiz. Watch parts of the video again, look back at the formulas or examples as you tackle the homework. I would do this homework with good integrity, meaning don't find yourself getting too much help from someone else. Make sure you finish the worksheet knowing how to do those problems, because these are the ones that give kids the most trouble on our upcoming quiz, especially this. They just forget that they need to understand the concept and relationships with tolerance. also paying attention to when I see an inequality mixed in with my equations, how am I going to know to set it up as an and or an or? Because if you can't take that first step, it's real tricky to get the right answer. All right.